All right, strap yourselves in for another trip down Bizarre Boulevard because we're diving into the world of fish that walk.
Oh, yeah. Fish that walk.
It sounds like something straight out of a creature feature, right?
Yeah.
But trust me, this is the real deal. Way more bizarre than anything Hollywood could dream up.
Makes you wonder what else is lurking out there.
Exactly. We're talking about creatures like Tiktaalik roseae, a 375 million-year-old fossil. This thing's a total mashup of fish and tetrapod.
That's the scientific term for four-legged animals.
Right, four-legged animals, which is strange enough on its own, but get this. It had a head like a crocodile, scales, fins.
Oh, and don't forget the front fins.
Oh yeah, those front fins were basically arms, complete with elbows and wrists. I mean, come on.
It's pretty wild. Tiktaalik is kind of a rock star in the fossil world because it gives us a glimpse into a pivotal moment in evolution, like a snapshot of when our fishy ancestors were first venturing onto land.
It's mind-blowing to think about this thing crawling around millions of years ago. But hold on, Tiktaalik isn't the only fish with a walking story. We're going to be looking at other walking fish, some that, embrace the whole land-dwelling thing.
And some that took a very unexpected turn. What's really fascinating is this whole transition from water to land. It wasn't like a one-time event. It was this gradual process happening over millions of years.
Oh, so you're saying it wasn't just like poof fish on land?
Nope, not at all. It was a long process with all kinds of creatures evolving all sorts of strategies for navigating between those two worlds.
Wow. Okay, let's break down Tiktaalik a little more. What exactly allowed this thing to make those first forays onto land? I mean, was it really taking a stroll on the beach 375 million years ago?
Maybe not a leisurely stroll, but it could definitely support its weight on land. Tiktaalik had these incredibly strong weight-bearing fins. They were practically like primitive arms.
Oh, wow.
They even had bones similar to the upper arm, forearm, and wrist bones that we see in tetrapods today.
So they weren't just flopping around on the shore. These fins were actually designed to hold it up.
Precisely. And here's another cool detail. Tiktaalik also had this flattened head with eyes positioned right on top.
So it was lurking, peering up at the surface, like a crocodile, waiting to ambush its prey.
That's exactly what we think. It really paints a vivid picture of how Tiktaalik might have been living and hunting in that shallow water environment.
Amazing.
Oh, and we can't forget the nostrils.
Ah, the nostrils, giving us clues that it could breathe air.
You got it. A huge step towards life on land. It's wild how features that initially helped these fish survive in the water ended up being perfect for life on land.
I know, like they were prepped and ready to go.
Exactly. That's what we call pre-adaptation.
Pre-adaptation.
Yeah. Traits that evolve in one environment but then prove to be super useful in a completely different one.
Oh, I get it. So, like, evolution had a plan all along.
Well, not exactly a plan, but definitely a lot of opportunities for things to change and adapt. And speaking of adaptations, there are actually some fish alive today that can walk on land.
Really?
Have you ever heard of mud skippers?
Oh, yeah. Mud skippers, those little guys that you see in nature documentaries.
Exactly. Mud skippers. They're like the poster children for walking fish. They hang out in those muddy areas, mangrove swamps, tidal flats, and they use their pectoral fins to scoot around on land.
I've seen them kind of hopping around. It's pretty cool.
It's not just hopping. They can move pretty efficiently using those fins. And get this, they're not just surviving on land, they're thriving.
Wait, really?
Oh, yeah. They find mates, they defend their territory, all that jazz. It's a whole other world of fifth behavior that we're just starting to understand.
It's like a fish social club out there on the mudflats.
Something like that. And then you've got the walking catfish.
Oh, yeah, the walking catfish. I've heard stories about them going on these epic overland journeys.
You heard right. They're known for being able to travel over land, usually to escape drying ponds and find new watery homes.
They just kind of wriggle around, right?
Yeah, they wriggle around using their pectoral fins. It's a sight to behold.
So we've got ancient fish venturing onto land, and we've got modern fish still doing it today. But what's happening on a deeper level, like genetically speaking, are these walking fish connected to us landlubbers?
That's where things get super interesting. Scientists have been studying this cartilaginous fish called the little skate.
The little skate?
It's related to rays and sharks, and even though it's not exactly a close relative of ours, it does something pretty remarkable. It walks underwater.
It walks underwater. What does that even look like?
It uses its fins like legs. It's almost mimicking the way we land animals move.
No way.
It's true. And here's the really wild part. Scientists have found some surprising similarities in the gene expression patterns that control limb muscles.
So you're saying there were similarities between us and this little skate?
Yeah, in a mouse, a chicken, and, believe it or not, the little skate.
That's wild. So even though they evolved walking totally separately, there might be some underlying connection in their genes.
That's what the research suggests. It points to the possibility that there's this ancient genetic blueprint for walking buried deep within our DNA that's been passed down for millions of years.
It's like this hidden code for walking, just waiting to be switched on.
It really makes you think, doesn't
It
it?
really does. This is incredible.
It raises a lot of questions about the origins of walking and how this complex behavior might have popped up multiple times throughout history. It makes you wonder how many other times walking has evolved throughout history. We might be surprised by what we find if we keep looking.
Okay, but if walking is so deeply ingrained in our genes, is it possible that some of those modern walking fish we talked about, like the mudskippers, the walking catfish, could they actually evolve to become fully terrestrial again? Like ditch the water completely, become full-on land animals?
That's a question that has evolutionary biologists really thinking hard. There's no way to know for sure, but it's definitely possible.
Wow. So we could be seeing the very beginning of a whole new wave of land walkers. It's like evolution hit the rewind button. First, fish evolved to walk on land, and now their descendants might be heading back. Talk about coming full circle.
It all comes down to the fact that evolution isn't a straight line. It's more like a branching tree or even a tangled web.
Oh, I see.
Lineages, they split off, they merge together, and sometimes they even circle back in these surprising ways.
And that brings us to Waikiki,
Ah, yes.
like close relative of Tiktaalik.
This little guy is kind of the rebel of the family, the one who decided to ditch the whole walking thing and just go back to being a full-time water dweller. Talk about an evolutionary U-turn. Kikitania really throws a wrench into our understanding of evolution. I mean, here we have this creature closely related to Tiktaalik, which was on its way to becoming a land dweller. But then Kikitania just takes a hard left turn and goes back to being a swimming specialist. Like, it looked at its land-walking cousins and said, nope, not for me.
Okay, so what made Kikitania give up on land? Like, was it just not cut out for the terrestrial life?
Well, let's look at the evidence. Kikitania's humerus bone, that's the bone in its pectoral fin that's equivalent to our upper arm, it was smooth and boomerang-shaped. Completely different from Tiktaalik's humerus, which had all sorts of bumps and ridges. Those bumps and ridges are where muscles would have attached, allowing it to support its weight on land.
Ah, makes sense.
But Kikitania's humerus, it tells us that it couldn't even stand, let alone walk.
So it was basically built for swimming and nothing else. It's almost like it evolved to be a better swimmer than its ancestors. Like it took a step back to take 2 steps forward.
That's a great way to put it. By losing those land-dwelling adaptations, Kikitania was able to become more streamlined, more efficient in the water. It's a good reminder that evolution isn't always about becoming better in some absolute sense.
Right.
It's about being the best fit for your environment. And sometimes that means going back to your roots.
Maybe Kikitani took one look at all the challenges on land, the predators, the harsh conditions, and decided, you know what? The ocean is pretty comfy. I'm good here.
And the ocean, it offers a ton of resources and habitats. It's not surprising that some lineages would find success by returning to a fully aquatic lifestyle.
So where does that leave us?
Yeah.
We've got these ancient fish evolving to walk on land, modern fish still doing it, and even a fish that decided to go back to the water after his ancestors had already made the leap.
Yeah.
It's like the evolutionary tree is more like a crazy maze than a straight path.
Exactly. Evolution is this constant dance between organisms and their environment. Adaptations, they appear, they disappear. Lineages, they split and merge, and it's all driven by the pressures of survival and reproduction.
And sometimes those adaptations lead to some pretty mind-blowing twists and turns. It's like the natural world is full of these surprise detours.
And that's what makes it so interesting. It makes you wonder what other secrets are hidden in the fossil record. Are there even more examples of these evolutionary reversals out there? More unexpected detours in the history of life?
It makes you wonder if we'll ever fully unravel this tangled web of evolution.
That's the beauty of it, though, isn't it? This constant sense of discovery. There's always something new to learn, something new to uncover. It's like peeling back the layers of a mystery that goes back billions of years.
It's crazy to think that we've only just scratched the surface of this whole world of walking fish. We've got Tiktaalik making those first steps on the land, and then you've got your modern-day mudskippers and walking catfish doing their thing. And then there's Kikitania deciding to go back to the water. It's like evolution's playing a game of what if.
Right. What if fish evolved to walk on land again? What if they ended up being the dominant land animals? It really opens up your mind to the possibilities. Like, what if Cricketonia hadn't gone back to the water? Would we have a completely different ecosystem on land today?
It's amazing to think about all the different paths that evolution could have taken, but I think it's time to bring it back to what we do know. What can all of this tell us about evolution?
It tells us that evolution, it's messy, it's unpredictable, it's not about some kind of linear progress or achieving perfection. It's all about constant change. It's about adapting and sometimes even going back to what worked before.
Makes sense.
It challenges how we think about how life is supposed to evolve. And it reminds us that nature is always full of surprises.
It also shows us that we as humans, we're part of this grand evolutionary story.
Hmm.
Like, we share a common ancestor with those first fish that crawled out of the water.
It's humbling to realize that our own existence is so closely tied to the evolution of these creatures, isn't it? We tend to think of ourselves as separate from the natural world, but the truth is we're deeply connected to it. And our own evolutionary journey really demonstrates the power of adaptation and how interconnected all life on Earth really is.
Well, I think we can all agree we've learned a lot about the world of walking fish. These creatures, they really push the boundaries between land and water. They've adapted and evolved over millions of years, and they continue to amaze us with how strange they are.
Absolutely. And it just leaves you with this sense of wonder, makes you want to keep exploring, and reminds you that there's so much we still don't know about the natural world.
Exactly. So keep your eyes open because you never know what amazing creatures are out there just waiting to be discovered. And with that, we're wrapping up this episode of Bizarre Boulevard. Thanks for joining us on our adventure into the world of fish that walked out of the ocean.
Until next time, keep exploring.